Okay, our goal for the 10-2 notes is to use combinations, and we'll talk about that as our key word for today. Wanted to screen shade this for you a little bit. To start off today's lesson, however, you really want to have a pretty strong understanding of how to use your calculator to evaluate factorials and permutations. So I would like you to take a moment, press pause, and do the warm-up, evaluate the expression below. So now that you've taken some time to do the warm-up, you also want to take a minute to check yourself. I did show some work again for number 4. 7p5 evaluates down to 7 factorial over 7 minus 5 factorial, or the quantity rather of 7 minus 5 factorial. And then that cooks down to be 2,520. You'll want to make sure that you are, on your homework and on your review assignments, please make sure that you're setting up this part of the problem. We're going to do a slight variation on this formula today, and I would hate for you to get the two confused. It's really important to practice at least setting up the permutation so that you have the formula in your head. And then for number 5, you could have done that as a permutation, or you could have done it with the multiplication counting principle. Any way you slice it, you would get 720. So now we're going to go ahead and just take a moment right now to jot down the definition of the word combination. And the word combination is defined as a selection of R objects from a group of N objects where order is not important. That's the key phrase there, not important. With permutations it was. We needed to know every single way to arrange N objects. However, with a combination, we don't care about the order. We just want to grab some items off the shelf. So we have a selection of R objects from a group of N objects where order is not important. You could also think about this as a subset of the number of permutations of N objects taken R ways. So let's talk about that last part of the definition for just a moment. You'll see my next slide here is not in your notes. It is purely for your visual entertainment. So you could just kind of sit back, relax, maybe you have yourself a Coke, and just kind of watch and enjoy, absorb a little information. So here in the first column you'll see I have 2 letter permutations for the letters in the word math, and you can plainly see that the word math there has 4 letters. And then over on the other side here, we want the 2-letter combinations for the letters in the word math. And again, we have 4 letters in our word math. And again, in this column here, we're focusing on combinations. In the first column, we're focusing on the 2-letter permutations for the letters in the word math. So if I'm looking at the permutations, 2-letter permutations in the word math, I'm talking about MA and AM. I'm talking about TH and HT. I'm talking about MH and HM. I'm talking about AT and TA. I'm talking about, we have to do HA and AH. And we could do MT and TM. And let's see here, how many do I have? 4, 6, 8, 10, 12. You might be okay. I'm going to run my NPR formula on this, 4P2, just to check to make sure I did get all of the 2-letter permutations of the 4-letter word math. So I have 4 factorial over 4 minus 2 quantity factorial. This is 24 over 4 minus 2 is 2 factorial. So 24 divided by 2, well, bam, is 12. So I do know I have the correct number of 2-letter permutations because I have all 12 options there. I have 12 different arrangements of 2 letters for the word math. Okay, now combinations, the difference, the visual difference between the two. We notice in our definition if I scroll back a slide here, we'll notice in our definition I underlined it because it's super important. In combinations, order is not important. So I don't need all of these arrangements. You know, out of the MAAM arrangement, I just care that I get 2 of the letters. And out of the ATTA arrangement, you know, I just need 2 of the letters. And out of the THHT, I just need those 2 letters to be represented. Order doesn't matter. Order is not important here. And then out of the, you know, ATAH, oops. Yeah, we can get rid of that one. I just need the A and the H. And then out of the MHHM, I just want those 2 letters to be represented. And likewise for MT and TM, you know, I just want those 2 letters to be there. I don't necessarily need every arrangement of them. And it's in this regard that we actually see the second part of our definition coming through. I had 6 options for the 2-letter combinations for the letters in the word math. So it was smaller. And now I want you to draw your attention to the second part of the definition. It's in this regard that a combination is actually a subset of the number of permutations of n objects taken R ways. It's going to be a smaller number because I don't need all of the different options. I just need a group of them. That's what the word subset is. It's just a small group of the whole, small part of the whole. We do have a formula for this, and I'm going to verify the formula on that next slide also. We have combination of n objects taken R at a time. And again, you're going to be using your calculator, but I want to remind you that there's a formula that goes along with it. So we're finding NCR. And again, we're going to do our n factorial over n minus r factorial. But because we don't need all of those arrangements, we can divide out another r factorial. So your formula for your combinations is just n factorial over the quantity of n minus r factorial times r factorial. I'll put that product in there for emphasis on the bottom. In your calculator, we talked about how to find permutations. You might recall that combinations also made an appearance. So if we wanted to find a number of combinations, you would have to store your n value, and then you're going to press math, arrow over to PRB, which is short for probability, and then option 3, you'll see there, is NCR. So we're going to be using those keystrokes quite a bit as we move through this particular lesson. So we have math. You're going to arrow over to PRB, and you're going to choose option 2, which was our, I'm sorry, option 3. 2 is permutation. There we go. All right, so let's practice. We're going to practice with this little slide I have here. I'm going to use my combination formula. I had 4 letters in the word math, and I wanted them pulled out 2 at a time. Order wasn't important. I just needed the 2-letter variation. So I'm going to do 4 factorial over the quantity of 4 minus 2 factorial times 2 factorial. So I have 24 over 4 minus 2, that's 2 factorial, and then times 2 factorial. I have 24 over 2 times 2, and 2 times 2, you know it well as 4. So how about it? I get 6 different 2-letter combinations for the letters in the word math. So let's do another word problem here. We have some books. You are picking 7 books from a stack of 32. Just picking them. So it doesn't sound like order is important whatsoever. I don't want them in alphabetical order. I don't need them in order by author. I just want 7 books from a stack of 32. And furthermore, they say, if the order of the books you choose is not important, how many different 7 book groups are possible? You're going to need to keep an eye out for wording such as this. If they come out and they tell you that the order is not important, a little light bulb needs to go off in your head, and you're like, hey, order's not important, I just need the combinations. I just need to yank 7 books off the shelf. So this is definitely verbiage that lets you know you're dealing with a combination problem instead of a permutation problem. On Tuesday, we're going to go ahead and spend time really working out the difference between the two. So we'll get some practice in class. And if you take a look here, we have 32 items. So my number of items, I have 32 textbooks, and I need 7 of them. So I'm going to pull out 7. So my formula set up for this guy is going to go 32 items, arrange 7 ways, pull out 7 of them. So I have 32 factorial over 32 minus 7 factorial times 7 factorial. And what I see here, I'll go ahead and go to my calculator to put that in. You folks know that you're going to have to store your number of items first. It works very similar to the way we did permutations in our calculator. So you're going to press 32, math, arrow over to probability. The third option down is combinations there, and I needed 7 of these books. So we get that number there. 3,365,856 is the response that you'll go ahead and put in your notes. Okay, so I'll go ahead and have you hit pause for a second. At this point in time, I would normally say, is there any questions, and give you a second to look at it. So I'll do the same. Okay, and in our next slide here, we start to get into a little bit more about the real meat and potatoes in this chapter. And the overarching goal in this chapter is to, for sure, calculate probabilities. And really what we're going to end up talking about at the end of the chapter is the multiplication rule versus the addition rule. But this is just sort of a preview of coming attractions. And then we're going to use these ideas on this slide here to sort of calculate some probabilities just initially. So the first bullet says, you know, am I supposed to multiply or add these probabilities together? And when finding the number of ways both event A and event B occur, so focus on the word and. If you see the word and in your problem, we're going to multiply the probabilities together. However, if you're finding a number of ways that event A or B could occur, you just want A or B, we're going to add our probabilities or our combinations or our permutations together. So with that, we have a word problem, and I'll go ahead and give you a moment to read it. Okay, so now that you've taken a moment to read just the problem, I wanted to dissect a little bit what you read a little bit. So what we see here is we have 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. As we move through the chapter, you're going to definitely notice that it's always important to find the total number of items. Really does help quite a bit. So what I noticed here, just initially, is that if I have 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies, it's probably going to be a useful piece of information to add those items together. So keeping in the back of my mind, I have 41 family movies. And then taking a look at part A. I noticed right off the bat, that the slide that I just filled in is going to come into play. You want exactly 2 comedies and 3 family movies. How many different movie combinations, oh, look at that, the word combinations right in the problem, can you rent? So that's just some important information to draw your eyes to in part A. And then in part B, you want to think about affording at most 2 movies. So when you think about affording at most 2 movies, what you need to think about is that's kind of an or problem in disguise. What that means is that you can rent, you know, with your money, you can rent no movies because you're broke as a joke, or you can rent maybe 1 movie or, at most, you're allowed to rent 2 movies. So you can rent 0, or you could rent 1, or you could rent 2. When you see this at most, at least business, what I need you to start to think about is that those are also or problems in disguise. And then it says, how many movie combinations right in the problem, can you rent? So we see and for part A and an or sample for part B. Now let's break down part A. It says you can choose 2 of the 12 comedies and 3 of the 9 family movies in the problem. So essentially what we're doing, if we're just choosing 2, our R value for the first combination becomes 2, and then the N value for that first combination is 12, because you can rent 2 of the 12 comedies. And then they wanted, in part A, also 3 of the 9 family movies. So you can rent 3, so your R value is going to be 3, and your 9 family movies is how many total movies there are. That's our N, our number of items. So the number of possible sets of movies can be found by just doing 12C2 times, and we did times because of the word and there, 9C3. So if we set up our formula, what we actually have there is 12 factorial, that's n factorial, over n minus r factorial. 12 minus 2 is 10 factorial. And then I have to divide out that r value factorial once again. To do the combination formula on 9C3, I have 9 items. And then I have to divide that by 9 minus 3 factorial, which is 6 factorial. And then divide out 3 factorial. And then you lean on your calculator a little bit. 12C2 evaluates to be 66. And 9C3 evaluates to be 84. And when you multiply these two numbers together, you get 5,544. Taking a look at part B, the problem says you can afford at most 2 movies. And then we are asked to establish how many movie combinations can you rent. And since it was at most 2 movies, we did say that that's kind of an or problem in disguise. So we could rent no movies, 1 movie, or 2 movies. And it doesn't really say what genre. I mean, these could be comedies, action, pick your pleasure there. If you like suspense movies, you could pick from those only. But in general, the total of options we have, there are 41 total movies to choose from. So that sort of increases the number of options we have to choose from. We're not just going to pick from one genre this time around. That wording isn't indicated in the problem. So again, I have 41 movies that I could choose from, and if I have no money, I would choose 0 of those. Or I could choose 1 movie from the 41, or I could choose 2 movies from the 41. And then I would go ahead and I would evaluate those. Well, 41C0, we talked about that, that's just 1. And then if you're choosing 1 of the 41, that's going to be 41 movies. And then to choose 2 of the 41, the different ways to choose 2, 41C2, in my calculator, that would yield 820. So notice I'm also adding these together because this was an or problem in disguise. So that's where those plus signs come from. So I added those things together and we get 862 movie combinations to choose from. So it's at this point in time I'd like you to take a moment and work out your independent practice problems. So go ahead and hit pause. And then when you hit play again, you're going to see the answers appear on your screen. Okay, so as you look at your independent practice conclusion questions, there are your answers. So you can go ahead and press pause to check those. Just to talk a little bit about example 4, please notice that the word and was in the problem, so I had to multiply the 2 sets of combinations together. You'll see that my R value was 2 in both because it did say that I was to choose 2 action movies and 2 dramas, and there were 8 action movies and 7 dramas to choose from. So that is how I set up number 4. Hopefully that went well for you. I did want to talk about one last problem, and hopefully you did maybe bring your textbook home or you have access to the online book. But I did want to just talk briefly with you about number 13 on page 694. I did say I would help you get a jump start on your homework on this video, and I'm just going to hold up to my promise there. So I'll read it out loud so that you can kind of take a minute to help yourself absorb the problem. I got to get my page here. 1 second. Okay, so hopefully you took that moment to open up your textbook also. To read the directions together on page 694 for problem number 13, the directions say find the number of possible 5-card hands that contain the cards specified. The cards are taken from a standard 52-card deck. So essentially, in number 13, the problem reads 5 face cards. This is me copying the problem. You do the same. And just a reminder, face cards, by the way, are things that have faces on them. So kings have faces on them. Queens have faces on them, an eyes, nose, and a mouth. And jacks have faces on them. Students will often ask, aren't aces face cards? No, aces don't have faces, so those get excluded. So you got to kind of think about just a little bit the original directions again in the problem. And it does say find the number of possible 5-card hands. 5-card hands. So you're going to get a, if we were playing this game right now, you would get 5 cards, is what that's saying. So we're asked to find the number of possible 5-card hands that contain the cards specified. Now, you need to think about how many face cards there actually are. Please keep in mind that there are 4 suits. The 4 suits are aces, spades, hearts, and diamonds. So there's 4 total. And then in each of these 4 suits, we have 3 face cards. So if I want to find the total number of face cards, the total options that I have, I just take 4 times 3. That's a total of 12 cards that I want to fall in my 5-card deck. So if you want to think about it this way, it's kind of as if we have 12 face cards total, and they're arranged or pulled out to make a 5-card hand. Because I need my hand to have 5 cards. Essentially, this breaks down to be a pretty simple combination problem. The way if I read it this way, what I see is that my number of items is 12, and then the number of ways I'm going to pull them out, my arrangements, is 5. And so I can pretty easily set up my combination problem to read 12C5. And then practicing setting up the formula, we do 12 factorial over 12 minus 5 factorial times 5 factorial. And then I go to my calculator and I'll type in 12C5. So 12, math, over to probability, down to option 3, and then I needed 5 cards. So I have 792 as my answer for that particular problem. You can get this hand 792 different ways. And hopefully that gets you a jump start on 13, 15, and 17. And then we will go over these at length again tomorrow. You're also probably going to be asked to do 14, 16, and 18 tomorrow as well. Well, good luck completing the rest of your homework, and I'll see you tomorrow.